Hi everyone. Let's start the preparation of carbon compounds today. This is regarding the carbon compounds like methane, ethane, or alkenes, any alkenes or any alkynes, or alcohols, carboxylic acids. How are we preparing them in the laboratory methods, right? So laboratory preparations of some important compounds here coming up your way, which is first methane. Methane. So how do we prepare that? It is CH3COONA. This is acetic acid salt. CH3COONA. How do you show it as your figure, as your structure? C double bond ONA. This is the structure of it, plus NaOH. That gives you Na2CO3 goes away, Na2CO3, all this goes off. So which is Na2CO3 plus CH4, right? So this has been released there, same thing happens, and it is in the presence of calcium oxide at 300 degrees Celsius. In the presence of calcium oxide, 300 degrees Celsius. Similarly, if I go with CH3, C2H5COONA, C2H5COONA, this is sodium ethanoate. This is called as sodium ethanoate. It is like, acetic acid and you have, two carbons, you have CH3, C double bond OH. In the place of H, you have sodium, right? So that's the reason it is called a sodium ethanoate. And this is sodium propanoate. Propanoate, because you have three carbons here. See, two carbons here and one carbon here. It is sodium propanoate. Same again in the presence of calcium oxide and in the presence of fuming NaOH. So I would write that NaOH as well, plus NaOH will give us what? This Na2CO3 goes off here also. This Na2CO3 gets released, plus C6H6. So this is preparation of methane and ethane as well. Ethane and methane are prepared in these methods. Right. Now let us go on with another preparation. This is one type of preparation. Let's move on with another preparation here. Methods of preparation of methane and ethane only, from iodomethane and bromomethane. From iodomethane. So what is iodomethane? Iodomethane is CH4, right? In the presence of one hydrogen, you take iodo plus hydrogen, nascent hydrogen. That gives us CH4 plus HI. Okay, and similarly, it is C2H5I, C2H5I, iodoethane. This is so iodoethane. It is two carbon and then five hydrogens with I. This is what it is. Plus hydrogen here will give you C2H6 plus HI. Right. So this is from iodomethane, and here is from iodoethane. So you're preparing your methane and ethane. This is methane and this is ethane produced by these. And also there is another way. This is the second type, I can say. Yeah, number 3 type, we have methane is also produced by water, addition of water to aluminium carbide. Aluminium carbide is Al4C3, right? Because aluminium goes with +3, so carbon will be going up with plus or minus 4. I would write it as -4 because aluminium already is +3. So carbon has to be -4. When you crisscross it, this is how you write it. That is Al4C3. So from aluminium carbide, produced from aluminium carbide, and hydrolysis on this will give us CH4 plus aluminum. See, any reaction with water will always give you hydroxides. So which hydroxide? Obviously metal hydroxide. Hydroxide is OH minus, right? And obviously that has to be going up with a metal. Metal here is aluminium, so Al is +3. Now again crisscross, that would be AlOH thrice getting released. But the main product here we have to talk about is CH4, which is your methane. right? So this is one of the reactions what you can go with. And this is type 3. Then we have fourth method of preparation here is ethane from alkyl halides. From alkyl halides. Now, what is a alkyl halide? Alkyl is alkane minus one hydrogen. That is alkyl group. Alkane minus one hydrogen is alkyl group. So alkyl halide is CH3. CH4 is methane. So CH4 minus one hydrogen is CH3. This is your methyl group. And halogen is represented in the form of X. It can be any halogen, right? It can be generally we take, chlorines and bromines we generally take. Right, so we can go even with iodine also here. So this is CH3 iodine plus Na will give you in the presence of dry ether. Dry ether, this is called as Wurtz reaction and all, right? So in the presence of dry ether, what happens here is CH3 gets formed plus NaI comes out. You have to balance this. I'm not balancing the reaction. This is called as Wurtz reaction. Wurtz reaction. Okay, it can be Cl also, it can be Cl, CH3Cl हो सकता है. This is CH3Cl or CH3Br हो सकता है. Whichever, if it is CH3Cl, then NaCl gets released. If it is CH3Br, NaBr get released. So it goes by that one. So it's Wurtz reaction in the presence of dry ether, in the presence of a reactive metal. So you will be getting your, this is what ethane we got. See, check out one thing here. You have a single carbon. Okay, single carbon with chlorine, right? So this is chloromethane, right? This is chloromethane. One carbon you have, no, it is methane. But what is it produced here? It is ethane getting produced. So take two of them. So 2 NaCl, khatam ho gaya, NaI, 2 NaI, or 2 NaCl, whatever it is, and with 2 carbons with CH3 groups altogether. So that is your Wurtz reaction, very famous name reaction. This is very important. Next, so as we have done about with the preparations of alkanes, now let us see some reactions of alkanes. I think we have seen already the reactions of alkanes and all in the previous recordings, what we went through, but rather I would go with some very quick reactions to go with now. Substitution reactions. Since alkanes are saturated, which means no more things can be added to it. So it can go only with the substitution reactions. So it is like CH4 plus Cl2 will give us what? So all these are hydrogen, 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 hydrogen. Like Cl2 is Cl single bond Cl. Now what happens here? The bonds break. Now this H and Cl, it turns out to be your HCl. And then what is that you're left out with? We are left out with CH3 and Cl here. It is CH3Cl. This is what we are left out with. This is what is a substitution reaction. This is chloromethane. Okay, or monochloromethane, that is what we can say. Then the next substitution, what is this? This is CH3Cl. Now the same thing again, we take CH3Cl undergoes again with chlorine. What happens? Chlorine is single bond chlorine. What happens? Again, another substitution goes on. Now this turns out to be CH2Cl2 because, see, what is the CH3Cl? I'm showing you here, CH3Cl. Right? So now what happens? This hydrogen again goes off, will be again substituted by a chlorine there. So CH2, here a substituted chlorine comes up. So CH2Cl2 is what is getting released plus HCl. This hydrogen is going off and with Cl also because one chlorine is still left behind here. So that turns out to be your HCl group. And now the product formed here is CH2Cl2. Now along with that Cl2, if I put, again what you have to do, you should reduce one hydrogen and increase one chlorine. So it becomes CHCl3 plus HCl. Then again CHCl3 plus Cl2 should be able to give us what? Another hydrogen, you bring it down, substitute the chlorine, so it is CCl4 plus HCl. So can we do one more time? Why? We know we cannot do one more time because it is now CCl4, right? And CCl4, there is no hydrogen to get substituted on right now. So only these hydrogens will be substituted, and CCl4 is my final product here. No more no more substitutions allowed because we have no more hydrogens to go off. So the second product what formed here is the yellow product here is dichloromethane. It is methane, it is dichloromethane. And now it is CHCl3. The third product what formed is trichloromethane. And trichloromethane is also generally called as chloroform. Chloroform is that substance which are used in kidnapping and all in movies में दिखाते हैं ना, kidnapping के लिए जो chloroform use करते हैं, that is the same thing here, trichloromethane. And this is tetrachloro, four chloros here, and the structure is still methane structure. So it is tetrachloromethane. So monochloromethane, you can say it as monochloromethane, dichloromethane, trichloromethane, and tetrachloromethane. All right. So this is about your chemical properties done on the substitution processes, right? Now let us go with your alkenes part here. Or you can try it up with ethane, C2H6 के ऊपर same reactions try करो and let me know if you don't get it. Please ping me up. All right. So let's move on to the next part of it, which is alkenes. So initially we have done alkenes. Now it is alkene preparation. Alkene is CnH2n, if you remember. And alkane was CnH2n plus 2. And alkene is, you will have a double bond. Definitely. See, if you have 3 carbons, also you will have 1 double bond. You're just trying to fill up these carbons this way. And so this is how we can write the structures. You have a 2 double bonded covalent molecule. This is definitely. And double bond में एक sigma bond रहेगा. And the other is my pi bond here. Okay, and here the angle between these carbons is at 120 degrees. All this angle is 120 degrees here. All right, carbon, and so thereby it's a trigonal planar structure, what we can go with. It just looks like a fan kind of thing. It's a planar structure. Now let us talk about the preparations of ethenes, right? So preparation of ethene. So this we have already discussed in the chemical characteristics done in the previous chapter. Dehydration of ethyl alcohol. Dehydration of ethyl alcohol. Now, what is ethyl alcohol? 2 carbons with OH group. Alcohol is the OH group. I'm just trying to fill up these things. And dehydration in the presence of concentrated sulfuric acid at 170 degrees Celsius. Concentrated sulfuric acid is the best dehydrating agent, and it removes water. See, from this carbon, OH is going out, and from the next carbon, hydrogen goes out. Then what happens? Hydrogen gives away its electron here, and oxygen takes up an electron. Thereby, OH becomes OH minus. Hydrogen gives away its electron, thereby hydrogen becomes H plus. As you can see, this H plus and OH minus, H2O gets released there. Then what is that left out with? 2 carbons here with a negative. See, I'm left out with two hydrogens here with a negative charge on this carbon. Single bond, the other carbon, 2 hydrogens left out with a positive charge. Now, the left side carbon has a negative charge and the right side carbon has a positive charge. What happens is this electron is being donated here, thereby setting up a bond like this. One carbon's electron, the other hydrogen's electron given to it. So therefore, carbon, double bond, carbon, this is what you are left out with, 2 carbon and 4 hydrogens. C2H4 is your ethene getting formed there. So dehydration of ethyl alcohol will give us alkenes. Then you have a dehydrohalogenation of ethyl bromide. This is second process here. Second process, dehydrohalogenation. Dehydrohalogenation of ethyl bromide. Ethyl bromide. What is meant by ethyl bromide? You have 2 carbons and you have bromo here. Okay, you just have to now go on with this. And in the presence of aqueous alcoholic KOH, what happens here? Alcoholic KOH, this is K plus, and all this as OH minus, this Br comes out as Br minus, and this has the plus sign there, right? So I'm not telling you much about the mechanism going on here. So here bromine comes out with K. So that turns out to be your KBr, K plus and Br minus, right? So it is KBr. Then OH minus has to go with 1 H plus. So hydrogen here also goes away as H plus. अपना इलेक्ट्रॉन यहाँ पे छोड़ के H plus बन के बाहर. Thereby this H plus and this OH minus turns out to be your water molecule here. And then what is that we are left out with? See, we are left out with 2 carbons and 4 hydrogens. If you notice this part, there are 4 hydrogens still left out here. So it is 2 carbons and 4 hydrogens left out. Now the bond goes with a double bond. All right. So this is about your dehydrohalogenation. So what happened? What has happened just now here? Halogen also got removed. Hydrogen also got removed. So it is dehydrohalogenation we talk about. Then cracking of methane. So how do you do that? This is called as cracking of methane. Option type number 3, preparation number 3, cracking of methane. Cracking of methane. So one methane molecule, cracking of ethane turns to your ethane. Yeah. So this will be your ethane molecule at 500 degrees Celsius and silicon dioxides or aluminum oxides. That will give you CH2's double bond CH2 plus H2. Like we have 2 carbons and 6 hydrogens here. Then hydrogen gets released out and then it is only 2 carbons and 4 hydrogens that has to be left out with. Thereby you are gaining this CH2 double bond CH2 plus H2. This is what you get. This is ethene molecule getting released out of here, right? And if we have to talk about the chemical properties, again, as I told, the chemical properties we have discussed in the previous sessions, but still I will go on again also. Yes, chemical properties. Now, 2 carbons with CH2 group plus hydrogen. What happens here? Definitely hydrogen gets added on. Because it's a double bond, we still have lot of space and bonds get broken down. Then carbon, single bond, carbon, and this is CH3, single bond, CH3. Alkane is getting formed from alkene. Alkane is getting formed. Then we have halogenation. It is nothing but addition of halogen. So carbon double bond like this we have. and halogenation, so Cl2. So then what happens? One chlorine here, other chlorine here. So carbon, carbon, Cl here, Cl there, and the rest of all will be hydrogens only, right? C2H4Cl2 gets released there. So that is also addition. And so these are a few properties that we can talk about. Then let's talk about the alkenes, or we can go on with some oxidation properties also, like, any oxidation of any hydrocarbon, or I would say combustion of any hydrocarbon will give you H2O plus CO2, which means C2H4 plus O2, which is burning in the presence of oxygen, will give you CO2 and H2O only, nothing else. Here it is 2 and 4 hydrogens के लिए 2 यहाँ पे, and 2 oxygens के लिए यहाँ पे how many? Here we have 2 and 2, 4. So put a 2 in front. That's it, balanced. This is your property, your combustion of C2H4. Then we have something called as oxidation. Now, oxidation के लिए you will remember one process here. What we go is alkane to alkene. Alkane can be converted to alkene, and alkene can be converted to alkyne, and then alcohol, and then you have aldehyde, and then you have carboxylic acids. Now it is oxidation going on here. For oxidation, every other step you get the next element like this. If I take alkane and do oxidation process, and oxidation carried on in the presence of alkaline KMnO4 or acidified K2Cr2O7, alkaline KMnO4 or acidified K2Cr2O7. So as you take that, you will undergo oxidation, and reduction के लिए गाड़ी आपका पीछे आएगा. अगर गाड़ी पीछे आएगा तो reducing agent used is concentrated H2SO4 or lithium aluminium hydride, LiAlH4, or LiAl, H4 can be used for your reducing, things. This is your best reducing agent, I would say. Then we have a very important chemical property which we did not discuss in the past chapter is polymerization. So what is polymerization? Polymerization is forming polymers out of the monomer units. So I have C2H4, right? C2H4 is nothing but carbon, double bond carbon with 4 of this like this. So now this is one monomer unit. Like this, you should have many monomers linking up with each other. That is what is called as polymerization. Now, how do they link with each other? What happens here is they break up their bonds in between. See, this is what single bond, hydrogen, 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 hydrogen. Okay, and then another carbon, another monomer. This is another monomer of C2H4. Although it has to be double bond, this double bond gets broken down. And then what happens here? This double bond gets broken down and monomer unit to the another monomer unit. Again, this carbon, carbon, and hydrogen, hydrogen, all here, another monomer unit. See, C2H4 it is, same C2H4, C2H4, C2H4. All these are monomer units, just the bond differs because that has to get connected to another monomer unit. So that bond in between, the double bond has to break themselves. As it breaks up, it moves on with another monomer unit, thereby forming a polymer. Then this process is called as polymerization. Very important chemical property of alkene this is. Now coming up with alkynes. Now, if I have to talk about alkynes, alkynes have the general formula CnH2n minus 2. So alkynes are unsaturated hydrocarbons. Let us see the lab preparation of this. When we have calcium C2 CaC2, right? Calcium carbide. We have preparation from calcium carbide. How do I denote calcium carbide? Calcium has got 2 electrons, right? And carbon to carbon. Now, carbon to carbon should share 3 bonds because each carbon should have 4 bonds all around. See, each carbon 1, 2, 3, 4. Right here also 1, 2, 3, 4. The white ones are for the bottom carbon and the yellow ones are for the top carbons. This is calcium carbide structure plus H2O. And if I say H2O, this is H plus and OH minus always that gets splits up into. Now that is going to get formed with carbon, triple bond carbon with hydrogen each and calcium hydroxide. But remember one thing as a tip, if I am using water as my reactant, then definitely 99% of the cases you will get hydroxides released, right? So calcium carbide with water, hydroxide is released. Which hydroxide is it releasing? The hydroxide is OH minus, so it has to go with positive one. Right, so it will be going up with metal hydroxide, which is calcium is +2 and OH is -1, right? Calcium is +2, OH is -1. Crisscross karenge to calcium hydroxide you will get, and that is how it is formed. And this is for 2 carbons and all. Now, what if I use only 1 carbon? If I use from methane, can we prepare this? Yes, of course, we can prepare it from methane as well. This is first preparation. And second preparation, this is CH4. Now, this CH4, in the presence of electric arc at 1500 degrees Celsius, what happens here? Put a 2 in front of it, balance karne ke liye. Now I have C triple bond C with CH and CH here, plus 3H2 there. See, there is a, all these are hydrogen. Now you can see the balancing part also, it is done, right? So you have to go definitely with your balancing whenever you write your equation. Also your understanding of that equation also to be written for good marks, I would say. Next, coming up with properties, chemical properties of this catalytic hydrogenation. I would say this hydrogenation, as we have done many times till now. See, hydrogenation ante carbon, triple bond carbon with 1 hydrogen here, 1 hydrogen here, plus H2. H2 is hydrogen, single bond hydrogen. Now what happens? The bond breaks up, here 1 and there 1, right? So whenever I go with like this, so here comes up with my equation, carbon, double bond carbon, and with 2 of these things. So this is how we get. Now, 1 second, just a minute, let me charge it once. So properties is like, here it is catalytic hydrogenation, addition of hydrogen. Halogenation, then addition of halogen. Just C triple bond C with H here and H here plus Cl2. If I put 1 chlorine here, another chlorine there, then C double bond C, 1 chlorine here, 1 chlorine there, 1 hydrogen here, 1 hydrogen here, right? So this is what it gets. And now again, if I do plus Cl2, what Cl, single bond Cl, here the bond breaks, here the bond breaks, 1 chlorine here, another chlorine here, then carbon, single bond carbon, chlorine, 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 hydrogen and hydrogen, which means you have 4 chlorines coming up on the molecule with 2 hydrogens there. So this is addition. Addition has happened here, right? So these are the addition reactions that we talk about. Then we talk about ozone. Yeah, ozone is one such important compound, and we say this as ozonolysis. Ozone, carbon, hydrogen, triple bond carbon, and then hydrogen with ozone. Then what happens? It forms a hut kind of structure here. Oxygen, oxygen here. Then oxygen here, and then hydrogen here. Now this is called as acetylene. acetylene ozonide. So this is called as ozonide, a very, 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 very important intermediate that is formed during the reaction. So reaction with ozone, the process is said to be ozonolysis is being carried out here. Next, then you have oxidation of, ethine comes out to your oxidation, which means गाड़ी आगे जाना चाहिए. So your strong oxidizing agent use किया तो गाड़ी आगे 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 जाके carboxylic पे रुकेगा. Otherwise, if it is a mild oxidizing agents, you would go with the alcohol and stop there. Now, so as we come across the alcohol, now let's talk about the preparation of alcohols. Preparation of alcohols. So your laboratory method of preparation is C2H5Cl. This is haloalkane, chloroethane, or right, this is called as chloroethane or ethyl chloride. Also, we can say ethyl chloride is a general name. Chloroethane is your actual IUPAC name. And with NaOH, will give us what? This Na plus and Cl minus, it goes away as NaCl. Then you are left out with C2H5OH. C2H5OH. This is how it is. C2H5. As you can notice here, this is all your C2H5 and this is OH. So this is laboratory preparation. And then you have industrial method here. One industrial method is C2H4. C2H4, two carbons and double the carbons you have hydrogens. It is alkene C2H4 structure. Also, I would draw always whenever you do about your organic stuff, please make sure you write your structures. All right. Now, C2H4 along with the H2SO4 with H2SO4 will gives us what? C2H5HSO4, right? And plus H2 hydrogen gets released, that's different matter. And now this C2H5HSO4 plus water will give you C2H5OH plus H2SO4 gets released again. So this is called as hydration of ethene. Hydration of ethene is industrial preparation of this. Okay, and then you can go with fermentation of carbohydrates, the most important and very commonly used thing for your preparation technique. This is fermentation of carbohydrates, which is C12H22O11. This is cane sugar. Okay, cane sugar plus water as you dilute it. Okay, and as you keep on boiling it and you add some enzymes called as invertase. Invertase is the enzyme which speeds up the reaction and it causes fermentation. Okay, it undergoes fermentation and then C6H12O6 is released. Another C6H12O6 also. H12O6 also is released, nothing but it is glucose getting released. Okay, glucose is getting released there. Now this C6H12O6, you can count on those things also. See, this C6H12O6 on, subjective to zymase, there is a enzyme called as zymase and undergoes fermentation too. It forms a C2H5OH plus CO2 plus carbon dioxide is getting released, right? So these are important preparations of alcohols and chemical properties of alcohols, which we have enough discussed it in the previous recording. So please go through that hydrocarbon chapter, carbon and its compounds chapter. So please go through that. Let's not waste time in that. Next, preparation of acetic acid, right? Now carboxylic acid, preparation of acetic acid. And how is that prepared? Oxidation of alcohol will turn your thing to your acetic acid, right? It is C2H5OH plus oxygen. That turns out to be CH3CHO plus H2O. See, actually what happens, as we have already discussed, alkane turn to alkene, alkene to alkyne, alkyne to alcohol, alcohol to aldehyde, aldehyde to carboxylic, right? But this is what it is, aldehyde ban raha hai, but ye jo aldehyde ban gaya, this is very, very, very reactive. So what happens? CH3CHO subjective to another oxidation, further oxidation, and gives you CH3COOH. This is in the presence of K2Cr2O7. Acidified K2Cr2O7 is your reagent used here for oxidation. So oxidation of ethyl alcohol will finally yield you CH3COOH. Although this is not a one-step process, I have clearly shown you the two steps undergoing this process here. Okay, and then the next preparation, this is first preparation of acetic acid. And go with the next preparation of acetic acid here. Hydrolysis. Hydrolysis of ethyl acetate. Hydrolysis of ethyl acetate. Ethyl is two carbons, right? So this is CH3C double bond O, OC2H5. This is ethyl acetate, also called as ester. We have already discussed about the ester in the previous class. So please go through that recording very, very carefully. If not done that, please do that and come here. Please do the carbon compounds chapter and then come here. It will be easy for you to understand. Okay. So, and then H2O, hydrolysis of this ester, or this is also called as ester. Ethyl acetate is properly known, but general name generally is just called as ester, will give you CH3COONA plus C2H5OH. Now you got this CH3COONA as sodium acetate. Sodium acetate. Now from this sodium acetate, you can bring out your acetic acid. So these are the preparations which went through all this. And that is it about all your preparations of alkane, alkene, alkyne, then alcohols and carboxylic acids. Or we have done this aldehyde preparation also here, because in oxidation of alcohol, first thing what you get out here is your aldehyde here, CH3CHO. CHO group is an aldehyde group. So aldehyde preparation also being done. So all these preparations of these important carbon compounds, please go through them carefully. In case you don't understand this, in case you did not watch the first recording of the carbon compounds chapter, please do watch that and then you come to this. All right. Chalo. Bye-bye. See you then. Take care, bache.